What makes us stand out? I think that we didn't stand out until two things happened. One, the cognitive revolution of, I believe it was 70 to 30,000 years ago, when our brains essentially became rewired, and we realized that we were not just like other animals. Our brains rewired themselves and made us realize that we can run this show. We have that kind of power because of our cognition. And then, I would say far more importantly, a few to several thousand years ago, the first civilizations developed. What that means is we have the ability to lock up the food, as Daniel Quinn writes. And so we did, and that allowed us to go into overshoot for the first time. And civilizations popped up all around the globe at pretty much the same time. Once we came out of the last ice age, the temperature was cool, and it stabilized at a relatively cool temperature, about 13.5 degrees Celsius, global average temperature. That's only 1.5 degrees above ice age, which is 12 degrees Celsius, 54 degrees Fahrenheit. So temperature increased just a little bit, stabilized. Suddenly civilizations were popping up like trolls on YouTube, and people started growing crops, and that allowed us to go into human population overshoot, initially locally and regionally, and ultimately where we are now, which is at the global level. So I think that is the primary reason that human animals abuse our habitats so much more than other organisms do. We're still stuck with the brains of several 100,000-year-old organisms. The brains that are thinking flight or fight, and if I live for the next few minutes, procreate. So those are the big drivers behind every organism on Earth. Flight or fight, survive the here and now, and then if I get through that, make small copies of myself. And then if I get through that, accumulate material possessions. But that's really a distant third that only we do particularly well, and the occasional pack rat. Wood rat, technically. If there are so many active positive feedback loops, does that not make the scientific method pointless? I don't even understand the question, I don't think. The scientific method, which is really a process, not so much a method, has been developed so that we generate what's called reliable knowledge that withstands the test of time. Knowledge that gives us theories such as evolution by natural selection, and what we call a theory in the sense of science is something that we would call a fact in a court of law. So it's pretty reliable knowledge, in other words. That's the point of science as a process. And does that make the, if there are so many active positive feedback loops, does that not make the scientific method pointless? No. I think that the whole goal of science is to generate that reliable knowledge, to make us understand the universe and our place in it. And that's important here. I would strongly encourage you to read Edward O. Wilson's 1995 book, Consilience, the first significant attempt to organize and collate all knowledge since Francis Bacon did it in 1604, I think, with Novum Organum. Maybe it's 1620. So a wonderful book by Edward O. Wilson at Harvard, attempting to bring together the relevant knowledge and how it influences how we live. And so I don't think there is ever a time when science becomes pointless, regardless of what we know. Yes, there are many self-reinforcing feedback loops that had been triggered. The acquisition of knowledge still matters, at least to some of us. Understanding the multiverse and our place in it still matters, at least to some of us. And from my scholarly perspective, that's pretty much all that matters. In addition to the, common bodily things we have to do to stay alive, eating and drinking and eliminating what we eat and drink from our bodies, that sort of thing. But as a scholar, I am motivated to understand the way the universe works and my place and our place in that universe. And the feedback loops don't have anything to do with making that unimportant to me, in the sense that there are too many variables. Yeah, there are a lot of variables. There are so many that it's very difficult to understand. One thing that we don't understand at all, as nearly as I can tell, is the interaction between those self-reinforcing feedback loops. So we understand, for example, albedo. So we start to lose some ice. We lose the ability to reflect. And as the ice shrinks, we get bluer and bluer, darker and darker surfaces. We lose the albedo, and we understand that pretty well. What we don't understand is the interaction between that self-reinforcing feedback loop and, say, methane. Methane released from the relatively shallow continental shelves. So, is there an interaction between those? Probably. Do we know how it works? Can we put a number on it? I haven't seen anybody do that. And multiply that times another 6 self-reinforcing feedback loops, and I don't know that anybody's tried to put those kinds of things together into any sort of coherent body. I would love to see it. I feel like I did in my classrooms, and since I was the teacher and they were students and they were all looking at me, there was this expectation that I would start the class off. Right? That I would have something to say that would be of relevance to them, or they would just get up and walk out. Who could blame them for that at any time?